already 2 questions, yes, Christine. Find some space. Please, yeah. Sequences, and sequences are nothing more than, ladies and gentlemen, what? Patterns, numerical patterns, maybe? For example, let's just start with a simple one. How about this? Let me go phone. I was thinking about that. Sure, let's go there. 2, 4, 6, 8. 2, 4, 6, 8, 10, etc., etc., etc. Sequences come in either one of 2 forms right now. They come in what's called an arithmetic sequence. I forget how to spell arithmetic. Arithmetic. And the other one's called geometric. Arithmetic. With arithmetic, well, first we should say this here. Please understand, when we talk about sequences, we talk about terms, okay? And when the book shows you a sequence, or they might ask you something about a sequence, when you see it like this, let me do this 2, 4, 6, 8 thing here. Okay. The first number given is what's called the first term. 4 would be the second term. 6 is the third term. 8 is the fourth term. And 10 is the fifth term. So a lot of times they will write their sequence in some sort of a box-shaped chart graph that looks like this. Okay. Where the top number is what we call whatever number of the term it is. Okay. And the bottom is called the value of the term. Okay, so the first term's value is 2, the second term's value is 4, third term is 6, fourth term is 8, fifth term is 8, or fifth term is 10, or whatever there. Okay, now, when you look at terms, you always want to see what's happening between the terms. In other words, this. To go from 2 to 4, which is an interesting one, because you could say to go from 2 to 4, I multiply by 2. But that can't be right, because I don't take 4 and multiply it by 2, because I would get 8. So I'm not, this one is not a multiplication one, this one is an addition, because between each term, you are adding 2. Okay? And so on, and so on, and so on. And an arithmetic sequence, they say, is a sequence that has a common difference. Which in your terms, in 7th grade terms, a common difference just means that you get there by adding or subtracting. That's what this means. It's just our mathematical way to say that. By adding or subtracting. We always think of the word difference being connected to subtracting, but in this case, it's either by adding or subtracting. A arithmetic sequence, you go from term to term either by adding something or subtracting something. Now, a geometric one, did I write geometric down? No. A geometric one, you can probably guess. A geometric term is one that you get the next term by multiplication or division. For example, 2, 4 starts out the same way, but the next one would be 8, and then it would be 16, and then it would be 32, and then it would be 64, and so on, and so on, and so on. And again, if you were making the table, like we did above there, the first term is a 2, the second term is a 4, the third term is an 8, the fourth term is a 16, the fifth term is a 32. Okay, geometric ones, okay, they say has terms, a common sequence that has common factors. And now factors, we always think about multiplication, but we can also get division because what can you multiply that's by the same thing? Dividing by 2 is the same as doing what in multiplication? Anybody? Think about this. Have you ever thought about this? When you divide by 2, what do? You cut it in half. Dividing by 2 is the same thing as multiplying by 1/2. Dividing by 3 is the same thing as multiplying by 1/3. So that's why they use common factors here. Okay, geometric one is by multiplying or dividing. Jacob, did you have a question?
Yeah. What? Like, what happens if you have? Can you have
A combination of them?
Yeah.
No. Because you'd never be able to figure out the pattern if you did.
Well,
I mean, I guess you could say, okay, I'm going to multiply by 2, then add 3, multiply by 2, then add another 3, but that won't happen too much. It's always kind of going to be this. Now, when you see these, well, you know, let's look at this first. Let's look at both of these. The first pattern or the first sequence I gave you was what? That was at 2, 4, 6, 8, 10. Let's just take a quick peek at this. And this was term number 1, 2, 3, 4, 5. And the second one, term 1, 2, 3, 4, 5 was what? 2, 4, 8, 16, 32, right? Take a look at what happens if we graph these, and you'll see kind of a goofy difference. Maybe not goofy, but just a difference. If I were to graph these on a coordinate graphing thing, what will this one look like? Well, here at 1, right, it was 2, correct? 1, 2. At 2, it was 4. At 3, it was 6. At 4, it was 8. What kind of a shape am I going to get? Okay, a nice straight line. That is arithmetic sequences. They're always going to give you nice straight lines. What do you think is going to happen here if I graph the second one? Well, let's look at it. 1 is 2. Starts out the same way. 1 is 2. 2 is 4. Still the same. But 3 goes up a lot more. 1, 2, 3, 4, 5, 6, 7, 8. 4 actually ends up being 16, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this graph here actually looks like this. And it starts curving and gets like a straight line as it goes up. This is a geometric, kind of a graph of a geometric sequence. It's not a straight line, it actually starts slow and then kind of shoots right up there. As it would be. Now what they give you is this. They're going to ask you to write formulas for sequences. And let's see if we can't do that. I'm going to give you one more. Well, maybe we should look at the sequence we have. Let's go back to that first one again. What was it? First term was 2. Sorry, first term was a 2, second term was a 4, third term was a 6, fourth term was an 8, and the fifth term was a 10. Now, in math, for the term, we use the letter n. Okay, in our formula. And for the value, we use the letter a. So if I asked you, if I wanted to know, here's the question, A, value is A, okay? The letter A is the value of the term, and the letter N is the number of the term. So if I asked you, here was my question to you, what is the value of the 15th term? I want a formula that I can just plug that number in that'll tell me without me having to count. 15 wouldn't be so bad, but if I said 100 or 200, you don't want to sit there and count 100 times to figure out where you'd be at. What formula can we use to find that? Well, and here's what it would look like. The formula looks like this. The value, which is what I'm looking for, of this term, of what term, equals, what would I have to do to the letter N? What do I do to this line to get this line? Well, look at it. How do you go from 1 to 2? How do you go from 2 to 4? How do you go from 3 to 6? How do you go from 4 to 8? How do you go from 5 to 10? What are you doing? What are you doing to the N to get that bottom thing each time? You see? Here's where it gets a little confusing, because this is an arithmetic sequence, but to get the answer in the formula, you're going to have to do what, Sammy? Multiply by 2. I am taking 2 times whatever the term is. So when I have this formula, I can just take the number 15. It goes in for the letter N. And this first one here, this little thing is a subscript. This little N here, it doesn't do anything but label something. It's not really a real number. It just says the value of the 15th term is 2 times 15. So the value of the 15th term is 30. If I kept counting out 15 times, I would get 30. I am just doubling or taking times 2 that thing there. Okay, let me give you another one for example. What if we did, 4, 8, 12, 16, 20. There's my sequence. This is term number 1, term number 2, term number 3, term number 4, term number 5. Still looking at the same formula. What formula would I use? If I wanted to find A to any term, okay, what am I doing to the N to get the A? What do I do from this to get this? And it has to be the same for everything. What do I do with 1 to get 4, 2 to get 8, 3 to get 12, 4 to get 16, 5 to get 20? Grace, you are? Right, I'm multiplying by 4. 4 times whatever N is will give me that term. So if I said, what would be the 32nd term? You'd say, oh, well, I just know. A to the 32nd term is 4 times 32. And 4 times 32 is 128. That would be the 100. Now, lest you think you have that, let's do this. 3, 9, 27, 81, 243. Let's look at a geometric one. First term, second term, third term, fourth term, fifth term. And I said the same thing to you. If I wanted A to any term, what would I do to get that? And here it gets a little goofy here, because this is not a constant difference, this is a constant multiplication thing. What do I do with 1 to get 3, 2 to get 9, 3 to get 27, 4 to get 81? And here's one I wouldn't guess that you probably picked up right away. Let me give you a clue here. What's my common factor? 3. That's the same the whole time. This would be 3 to the n power. Because take a look, what is 3 to the first power? What is 3 to the second power? What is 3 to the third power? It's 27. So if it is a geometric equation or geometric sequence, it's going to be whatever that common factor is to the power of n. Or this could be n minus 1, or it could be something. Let me look and see what else they give you here. They say to write a formula here somewhere. Maybe not. Is there one where the same? Oh, we already did that one. Oh, no, they do this one. Here's one they give you that's a little different. Check this one out. Let's do the same thing. 1 is 1, 2 is 2, 3 is 4, 4 is 8, 5 is 10. Is that right? Sure. Let's call that good. So if I was writing my formula, first of all, what type of formula is this? One of those arithmetic or geometric? Does it have a common difference, or is it multiplying? Adding or multiplying to go from one term to the next? Well, multiply by 2, multiply by 2, multiply by 2, multiply by 2, right? So I know when I write my formula, a to the whatever term is going to have a 2 as its base number because I keep multiplying by 2. But the question is, what's going to go up here? It doesn't work if I put the letter n here. Why? Because 2 to the first power is not 1. 2 to the second power is not 2. It's 4. 2 to the third power. But what do you notice about this, though? I do get those numbers, except they're one place away, right? So what could I do if I knew my term was, let's say I was looking at the fourth term. We know that 2 to the fourth power is what? Wait, did I give me 16? What should have been? Okay. But I don't want 16, I want to get 8. I need to make my fourth term actually the third term. So what do I do with 4? To make it a 3, I subtract 1. Does that work if I say, okay, you need to take n and subtract 1 from it every time? Well, let's try. N minus 1. 1 minus 1 is 0. What is 2 to the 0 power? 1. What is, if I do my second term, 2 minus 1, 2 to the first power is 2. So this, and I don't think they'll give you a lot of these, so if you don't get this, don't touch. I don't know why my thing's not right here. 2 to the n minus 1 power. I don't think they'll make you write a lot of those sequences now, but that was just one that we used there. Look at page 418. There really wasn't a lot of them. Look at page 418.